So we begin this class. Very good day to everybody. Once again, this is technology, innovation and new media. And in this class, we discuss about the multimedia over the transmission control protocol. Actually, in this class, normally like networking means there will be only concepts. But here in this class, I will be also showing you a program for this multicast streaming. Okay. So this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students and young researchers. So in this class, we discuss about multimedia transport protocols. We have already studied about transmission control protocol. We'll discuss about its retransmission policy and procedures. Then we discuss about RTP, real-time transport protocol, about the disadvantages, what is the algorithm that we will be following, okay, and we will have a C code to actually demonstrate the TCP client server implementation. Okay, so that is for the server side we will have a code, for client side we will have a code, and we will try to establish the communication. Okay, so I will be giving you independent work for you. Please complete them. As I'm telling you, there are 10 independent works that has to be completed. At regular intervals, I'll be giving you some short videos to discuss the knowledge in our topics. This multimedia transport protocol. So whenever you are going to transmit these multimedia signals, maybe from one point to another, there is of course usage of bandwidth. Okay, there will be traffic constraints even, and everything we will be employing using a communication network. So using specific protocols, we will be establishing the connection. Okay. So here the multimedia original signals are encoded, so it is protected in order to reduce the bit rate. And when the encoded stream is sent maybe to another location, which means that we will be using specific protocols, nothing but like the transport protocols for packetization procedure and maybe for efficient delivery. Okay. So maybe at one side, from one side to another side, we will be having the for example the receiver side. Let us take in the case. We have already encoded in order to reduce the bit rate. The encoded multimedia stream is once again reconstructed, okay, again to get this original signal. Only then you can actually reduce the bit rate. Also, you can transfer without any problem, without any delay. Okay. So for this one, the encoding procedure is done. Again, reconstructing, then decoding the original signal is done in order to produce the useful multimedia signal. So if we are able to reconstruct, encode, reconstruct, decode means, so maybe we can play that signal, we can pause, we can do much stuff. Okay, so just like a video, you can fast forward, go back, you can pause, you can do much more stuff. Okay, so that is the reason we will be using IP, Internet Protocol, for exchanging data across the networks. So here from the host, okay, to another destination. Okay, so we are sending data 1, and whenever you receive the data 1, immediately it should receive an acknowledgement. So just like you say hello, you will ring it. Okay, immediately I say hello. So this is the acknowledgement we try to give. Okay, so it has a retransmission timer for the segment even, and for example data is lost means, so it is going to retransmit and you will be getting the acknowledgement. So this higher level protocol is nothing but the TCP, transport control protocol. Okay, we will be using for data transmission, especially in the internet services, that we will be using it to the maximum. And also you can also say that TCP is not suitable for real-time applications, because if you introduce the retransmission, for example a data packet is lost means, which means you should go for retransmission. So which means that more time it will be consuming, there will be higher amount of delay, and there will be a problem of jitter also. Okay, so this, if you can see, retransmission, if you allow means delay problem will be there will be degradation in the quality even, and of course in addition to it, it will not be supporting multicast, which means that transmitting, receiving at the same time, that is also not possible. So you should wait, and only then you should transmit, and this it is going to introduce the delay problem. Okay, so in the congestion control mechanisms, we will have slow start even, that is even not suitable for the audio or maybe video communication even. So that is the reason for real-time data transmission, you will be using user datagram protocol. So for real-time data transmission, you will be using user datagram protocol, but user datagram protocol also there is one small problem. Okay, so it does not guarantee this arrival of data packet. So it's actually up to this application layer or maybe even higher layer protocols even to take care of the data being sent. Okay, so that only that problem, especially except for that, then user datagram protocol is actually useful. Okay. So for real-time applications, you can build a protocol over the UDP. Okay, so that is the RTP, real-time transport protocol. So for real-time transport protocol, we'll be having timestamp, nothing but the TS, and then the sequence number. Okay, or maybe the serial number that will be specified. So here the timestamp is useful for placing the incoming packets in the correct timing order, and the initial value is selected randomly and independently for each real-time protocol string. Okay. Right. So this is the real-time transfer protocol. We will have the IP camera. We have the network computer. Okay. So we will be exchanging the HTTP request across the web server. Then here we will be having real-time streaming protocol. Okay. So that is the meta file with all the streaming commands that is associated. And in return, it will be exchanging the real-time protocol with the audio and video content. So HTTP, then RTSP, then only RTP. Okay. So here the timestamp, it's actually incremented for each of the time which is indicated for the packet. And for example, let us take in the case for audio transmission, like if you keep the packet interval to be 20 millisecond, so definitely your timestamp would be 20 millisecond means 0, 20 millisecond, 40 millisecond, 60, 80 and so on. For the respective packets 1, 2, 3, 4 and so on. Okay, so the sequence number will be actually identifying the packet losses and it will be incremented for each of the packet that is transmitted in the stream. Okay. So for the video frame, it is actually split into number of this RTP packets, real transmission protocol packets. Okay, and every packet, every packet will be sharing the same timestamp, but definitely it will be having different sequence number. Okay. So there is a separate control protocol even that's generally dedicated with the RTP, what you call to be RTCP, real time control protocol. So maybe for handling the error report, okay, for producing the error report. So the advantage with the real-time control protocol is that it is going to generate the receiver report. So it is going to give a feedback on the quality of the data transmission by using this last data packet counts in the receiver report. Okay. After the class, please. Okay. So it is going to identify, it is going to detect, and it is going to keep track of the number of participants. And for earlier you saw like every 20 milliseconds it is going to give the signals. Okay, sir. It is being sent. So for RTCP reports, it is being sent every 5 seconds between the participants with the restriction that the traffic should not exceed 5% of the total data traffic. Okay, so it is going to support multicasting, payload type identification. Of course, earlier you saw the times stamping, sequence numbering also the same, but in addition, delivery monitoring and report generation. So that you will be getting. Okay. So the user datagram protocol, it will be supporting both the multiplexing and the checksum operations even. Okay. But there are some disadvantages. The thing is that it is going to monitor, but it is not going to support the timely delivery of the data. Okay. Or maybe it is not going to guarantee the quality of service. Okay. So in time delivery, there is out time delivery also. So in time delivery, definitely it requires lower layers to have control over the resources in the case of switches or maybe routers. So maybe if you take in the case of resource reservation protocol, so the in time delivery is not actually monitored or maybe controlled in an effective manner. Okay. Also, like there is a problem of packet getting lost. So that is also one problem of the real time transport protocol. Okay. And for packet loss also, there is no definite mechanism to make guarantee or maybe make sure about this packet loss. Okay. So that is the major thing. Okay, so we come to this important part, the server client implementation, establishing a communication between the client and the server model using the TCP. So only problem is the retransmission time. except for that TCP is very good. Okay, so TCP definitely it is robust, highly reliable, and definitely the transmission time is less critical even. So maybe for hypertext transfer protocol, or maybe hypertext transfer protocol secure, or maybe file transfer protocol, or simple mail transfer protocol, or maybe telecommunication network, you can use the TCP client server implementation. Okay, so here it is going to rearrange, it is going to keep the data packets in order. Okay, and there is definitely a guarantee that the whatever the data is transferred will be in the same order. Even if it is not in the same order also, it will rearrange it and it will be arriving in the way it was actually sent. Okay, and with the case of TCP, it will be having like flow control, and definitely it will be having 3 packets to set up the socket connection. Okay, and definitely for congestion control or maybe reliability procedures, it has error checking, error handling, error recovery, that also can happen. And then the packets which are not transmitted, or maybe which is lost, or maybe packets which are having more error, are actually retransmitted from the source to the destination, and that is the problem it is introducing the delay. So this algorithm we can break down into the following steps. For example, you can use the create function. You can create a transmission control protocol socket. Then you can use bind function. You can bind or maybe put together the socket to the server address. Then maybe you can use listen function. So the server socket is actually put in the passive mode, not the active mode, where it waits for the client to approach the server to make the connection. And then you can use accept function. So the connection is established between the client and the server, and maybe it is ready to transfer the data. Okay, so once again you have to go with the listen. Once again it waits for the client to approach the server to actually make the connection. So the procedure is actually repeated. For the case of client, you are going to create a TCP socket just like this one. Okay, and you'll have this connection, the newly created client socket to the server. Okay, and this is how it goes, like server socket and client socket. So we'll have set socket out, and then bind, and then listen, and then accept, and then send or receive. Okay, so here we will have only connect, so that will be with the connection. Okay, and then send receive will be exchanged. So this is the C code, okay, for the TCP client server implementation. So you'll have hash include stdio.h, you'll have netdb.h, then you'll have hash include netinet./in.h, then standard library.h, then string.h. Okay, you'll have system/socket, system/types, then you specify the maximum port of 80, the port 8080. Okay, then you define the implementation. Okay, struct socket address, void function, the connection ft function, and you establish the buffer. Okay, character buffer, the maximum size int n. So you'll be specifying a infinite loop for the chat. Okay, so for this one, buffer comma max, and you read the message connection, the full duplex connection, buffer, size of the buffer, and you print the buffer which contains actually the client contents. So print f from the client modulus s/t to the client, from the server to the client. So actually we are writing the code for the server part, then we write for the client part. Okay, then b0 of buffer comma max n equal to 0, and you copy the server message in the buffer. Okay, so while buffer of n plus plus is equal to get character not. Okay, so you send this buffer to the client, and you are actually, if you can observe these steps. Okay, so first you have to set socket, then bind, then listen and accept, and then send receive. So these all steps has to be done in the server part. Okay, and that is the reason after you are going to go with the string compare exit and printf server exit and then break. Then you'll have the driver code in main function, in socket function, connection, and then length, struct socket address in the server address. You are going to append in the server address, and socket create and verification, it is equal to socket. You'll have inet socket string, and if this socket ft is equal to -1 which means that socket creation is failed, and you go with the exit 0. So now we are done with the server part. Okay, so we'll have two things. If either connection is lost, means you'll have this one, socket creation fail, or otherwise you can say socket successfully created. Okay, then you'll go with the b0 server address, size of the server address, server address in the family, you will be having the function, okay, and you will be having the server address in the port h tones of the port you are going to specify. And if the bind of the socket function service address is not equal to 0 means socket bind failed. So that is the binding procedure which actually failed, and you go with the exit of 0. Else case, you will go with socket successfully binded, and after binding, if you can see the step after binding, you will have listen procedure. So listen means you are going to establish the connection, okay, you are going to verify. So if the listen of socket fd comma 5 is not equal to 0 means listen failed. Otherwise you can say server listening, and you specify the length equal to size of the client. So after establishing the connection, you will be accepting the data packet from the client, and you try to verify. Okay, so connection equal to accept socket FT, server access, okay, the client and the length. So if the connection FT is less than 0 means server accept fail. Else case, server accept the client, which means that server is accepting the communication between the server and the client. Okay. So, and then the function that is there for chatting between the client and the server. So function you are going to have, and after chatting, you close the socket. So that is to increase the privacy or maybe the authentication part. Then same thing you are going to go with the client. If you can see this algorithm, okay, same thing you are going to create a TCP socket, and you are going to connect to the newly connected client socket to the server. So whatever connection we have established, this we are going to connect to the. So you'll have ARPA and then netdp, std standard library, string function, string s function, okay, and then system slash socket, and you'll be having all the functions for read, write, and close. Okay. So you define the maximum port of 80, okay, and define port of 8080. Same thing only. Like define socket address, the struct of socket address, void function in socket address, character buffer of maximum, int n. Okay, so this is nothing but an infinite loop. Okay, so b0 buffer, size of buffer. You try to enter the string. So why an infinite loop means actually we have established several steps are there in the server part. So it will be running across. Okay, so while buffer of n plus plus is equal to get character not, okay, so you write the socket, okay, fd buffer and size of buffer, and b0 you will be having buffer and the size of buffer. Okay, so same thing from the server we will be expecting this connection, and if this string compare is equal to 0 means client exit. Then same thing you will have the driver code. This is the driver code in main function, in socket ft connection ft, and struct socket address in the server address. So you will be creating the socket. Remember, for the client we had only 2 steps. Just create the socket, establish the connection, that's all. So you will be creating the socket. So socket ft equal to socket, you will be having the net address. So if the socket ft is equal to -1 means socket creation failed. Otherwise you can say socket successfully created. So we'll have the server address in the family. Okay, so inet address. Okay, so server address in the port equal to the port that you are specifying. So if the connect of socket ft server address, then you specify the size of the server address. If it is not equal to 0 means then connection with the server failed. Okay, and else case connected to the server, and there will be a function for chat just for communication. Okay, so function of socket ft, and you close the socket ft. Okay, so maybe if you can see compilation, so you'll go with this one, gcc server.c, okay, -o server. So if you have to do this one, so you can see all the process being created, like successfully created, successfully binded, then the connection, server listening, server accept, I mean from the client like hi, to client hello, from client exit, then to client exit. So afterwards you'll go with the server exit. And similarly client side, socket successfully created, connected to the server, enter the string hi, from the server you can say hello, and enter the string exit, from server also same exit, okay, and client exit. So this is how you can go with the connection. So these are some of the things. Very rarely you find C programs with these functionalities. Normally you will be experiencing this in this network simulator tool like NS2, NS3, or maybe NS4, but rarely you can apply. Environment work 6 or maybe assignment 6, demonstrate multicast on streaming of data using TCP and UDP socket programming using any programming language.